That was the best time I've had all day.
All right. So just while we're waiting on Vito to come back, Damo, basically this whole kind of problem is basically the idea is that there's 5 graves. We've got 5 graves. There's a mole in one of there's basically you're at a graveyard. There's 5 graves. There's a mole that's lurking around in the graves, and our job is basically each day we can dig up one grave, and each night the mole can move to a different grave, and it can only move to a grave to either side of it, and it must move. It can't be a lazy mole and stay in the same spot. It's got to move on. And so our job is to come up with a sequence of like graves to dig, such that we're guaranteed to find the mole. So if you take a look at kind of like, if you think of like these as the 5 grave positions, grave 1 to 5, if the mole's at either end of the graves, there's only one way it can move. It has to come back in a grave. As opposed to like if the mole's at grave 2, it could go 1 or 3. We don't know. It's really up to what the mole wants to do. So just to kind of make sure we're on the same page, what I've done is I've just quickly set up like this is day 1, right? So we're gonna assume that the mole is at the first grave on the first day. That's what we're gonna like kind of pretend like that we know that much information. We don't in reality, but let's pretend we did, and then kind of see where the mole will get up to. So if we say the mole is in grave 1 on day 1, right? So here it is. Here's the mole. It's just sitting there in grave 1. Say a night passes, so it can move. Where can the mole? Which grave could the mole move to after the first night? If it's in 1 for the.
Yeah, just 2.
Beautiful, right? Now you're getting it already, right? This is gonna be good. We're gonna move. We're gonna get through it. So sweet. So the mole's at grave 2 after the first night. What about the next one? Another night passes, right? So day 3, where could the mole be?
Yeah, so just 1 or 3.
Yeah, beautiful. So right now we're saying like this is where it could be, right? We don't know. It could be 1, it could be 3. We don't know exactly, but we know it has to be one of those 2. And so if we did the next night, what are we thinking then? It gets a bit more complicated.
2 or 4.
2 or 4. Yeah, is that? Yeah. Right. Brilliant. And I think, all right, so 2 or 4, and then I think the last night, what do we think?
Well,
1, 3 or 5.
1, 3 or 5, yeah.
Didn't even do it, but that sounds good to me, right? So we have 2. That if it was in 2, it'd go 1 to 3. If it was in 4, it'd go 3 to 5. Yeah. So okay, that's great, and that's all we're kind of doing here is we're just playing this game of like, let's see where the mole would be after n nights. So that's if the grave's at the first position, but again, we don't know where the grave starts.
I've got an idea.
Hit me.
If the mole is day 1, night 1 in grave 1, then in n nights, the mole is in grave 2. And that n is 1 night after 1 night. I solved it.
Yeah, no, you could go also, back to the.
Just to show like how I've thought about this a lot. If the mole on the first night is in grave 5.
Yeah.
If n is 1, grave 4.
No. That'll work. I reckon exactly. We just go back to the graveyard and say, look, we've got it. Now, all you've got to do is, this works as long as... Exactly. We can guarantee to work. As long as the mole's in grave 1 or 5, this will work. Hands down. No, I agree. It's a good start.
What are the rules of this challenge? Like, so you're trying to catch the mole in as little moves as possible?
Yeah, exactly. It's like 2 things, right? It's like, yeah, exactly what you said. It's like the least amount of moves or least amount of sequences that we dig up the graves, and we're guaranteed to get the mole. So it can't be
Cam reckons that eventually all these eventualities, like, it was after night 4, that it could be in either graves 1, 3, or 5, that, at night 36 or something, or at night 52 or at night 107, they all line up onto one grave. All those possibilities coalesce onto one. And then if you were to dig on that night, so it's not, let's say for argument's sake, it's night 99, you go, yeah, it's grave 3, then 100% chance the mole will be in grave 3. Now, I think this we're on a hiding to nothing. We'll never get there. It's impossible. And Cam's just pulling up. We're going to do this continuously every Monday. 37 Mondays until we all coalesce into one super developer.
Exactly. We go every week. We just dig up one grave. All right, that'll do it. See you next week.
Hey, can I just check something? That raises an interesting point.
Yeah.
How many? Do we get to choose what night we dig on, or do we just?
Yeah. So like Vito's right. With the only little extra information that we get to dig up a grave, like they won't naturally come to a single point, converge to a single grave. There's a secret, like us digging a grave each night, kind of.
Oh, that's right. Yeah, I forgot about that. You have to chase it in there. Yeah.
We chase it in, and kind of cutting out the possibilities down. So at one night, we guaranteed, okay, we've got it. We've got it regardless.
So okay. Yeah, I'm still just getting my head around it.
So does that mean that you also want to reduce the amount of goes? So for example, there will always be 5, like the maximum amount of goes you can have is 5.
Yeah, we're trying to get that few.
So we're trying to get that down to as few as possible.
Least amount of digs.
I mean, it could be 100 goes, 100 digs we need to get it.
But if you've dug up, didn't we say if you dig up grave 1 night, then you can't dig up that grave the next night, right?
No, you can. You have to fill it back in.
Oh, you fill it back in.
So it's like, go Damo.
Well, can you explain to me why, if you just run from 1 through to 5, you won't run into it?
Yeah, I mean that's kind of what I thought as well. It's like surely you just kind of can sweep it out by pressuring it into the grave. But the problem is that say the mole's in 1, or let's say it was in 3 or something, right? And we say, okay, first day, let's just dig 1.
Yeah.
And it's not there. So you go, okay, that's fine. Next night we'll dig 2. It's not there. You're like, okay. Now, then the mole says, all right, I'm going to move to 2. Then you go to 3, dig it, and it's not there. You dig 4, it's not there, it's not there. Because it can kind of jump on you that night before you want to dig it.
It's Caddyshack.
Okay.
We're basically playing Caddyshack here.
So you're not...
Has no one seen that movie, Rodney Dangerfield, Caddyshack, where they try and... No. All the gophers?
No, that's just...
Okay. Sorry. Just way before your time, guys. So,
yeah, I mean, it's that's above me. That's above my class.
If the mole can move after you check a grave, how is there any way to actually catch it?
This is the thing. Exactly. It feels like it should be impossible, is what it feels like. But there's
always a 1 in 5 chance at the lowest. What we're trying to work out is if there's is reducing that probability down to.
So if you are at 1 off either end, so if you're at 2,
yeah,
and you're assuming that it's in 1, do you have to change your grave as well, like that you dig each day?
So no, you keep digging 2 if you wanted. You're going I know one day hopefully it jumps into 2, and so that's a good example, right? You could say, hey, if you just keep digging the same grave, eventually, the probability will every time you dig will get closer and closer and closer to 1 that you'll get it. But that's not that. That would be like a solution, but it wouldn't be the shorter sequence. that sequence kind of
What about,
infinitely long.
what about 3? Just always dig 3.
Well,
Right.
well,
But
exactly.
does
It's
the
like if you just keep.
mole-
What's that?
Can the mole just stay in 2 if it wants to?
No, it has to move, but it can keep oscillating. It can go like 1 2 2 1 1 2 2 1 like.
Yeah.
So it's exactly like to your point, Damo. It's like if you just keep digging 3, or really digging just any of them, just over and over and over again, the chance that you'll get it gets gets higher and higher and higher as more like as you keep digging the same grave.
I think I've got an idea. So start at 3 on day 1,
Yeah.
then move to 2 on day 2, and then dig 2 again on day 3.
Wow.
So if it has moved to 1, it has been forced back to 2 on day 3.
Yeah.
And then if you still haven't got it at that point, it must be on your right-hand side. So you can move to 3.
So you're saying dig, was it 3 2 then what was it, Dave?
3 2 then 2 again.
Yeah.
And then if you still haven't got it at that point, move to 3 4 and 4 again.
Oh, I see.
Three, 4, then 4 again. All right. Well, you know what I do? That's great. You've given me a sequence. So from here, what we'll do is we're going to implement a function called check, which says, give me a sequence. Does it work or not?
Okay.
So that's kind of a nice little segue. I mean, the only thing I was going to do was show that we kind of. So I'm going to put here demos.
Commit.
But the only thing I was going to do was basically say, hey, we went through what would happen if we assume it's in the first grave on day 1. What would it look like if it was in grave 1 or 2 on day 1? Because we have to, at the end of the day, we have to assume it's in grave 1, 2, 3, or 4, or 5 on day 1. But we can see if we said if it's grave 1 or 2 on day 1, then we're kind of here, right? We say, all right, on day 1, the mole could be M1, M2 is like if it was in 1 and if it was in 2 on day 1.
They're like mole probabilities.
It's like, yeah, it's like, what are the little moley probabilities there? So if we said this, then after the first night, on day 2, where could the moles be?
2 or 3.
Yeah, 3 or 2.
Okay,
So
fine,
yeah.
Damo.
So we get, exactly, we get 1, 2, and 3, right? If we combine those two together, basically we get the fact that if it was in 1, then it had to move to 2. And if it was in 2, it could have moved to 1 or it could have moved to 3.
Yeah.
So we're kind of getting all this kind of like, if it's there, then it could be here. And if it was there, then it could be here. And so, come day 2, it could be in any of those graves. It couldn't be in 4 or 5 if it started in 1 or 2, but it could be in 1, 2, or 3.
Yeah.
And then that just gets...
My solution wouldn't solve that.
Yeah, that's the thing. It's like if we know where it starts, it's easier to find a solution that kind of pins it in. But when you don't know where it starts, it's hard to like leverage. You can't really take advantage of any information from the get-go.
Yeah.
And so like you can say after the 3rd day, it could be in 4 of the graves. On the 4th day, then it could be in any of the graves. And that's just if it was started in the first 2 graves. Now if you said, well, it could start in any of the first 5 graves and then watched each one as it could have been in another grave, that's where it gets a bit like mind-blowing. Like it's like, I can't keep track of all these moles. I'm a one mole man, a one mole mind. So I think let's have a crack at that check. So basically, Dan, what we did was we just defined an enum called grave to represent the graves. Then we got a type called guess sequence. So this was the whole idea, is that you could say like 1, 2, 3, and you can kind of define what your sequence of digs are.
Yeah.
The move function just says, give me a grave, and then I'll return you where the mole could move to. So, good example, 1 has to go to 2, but 2 could go to 1 or 3.
Yeah. These are like, again, possibilities. Possible
What's that? Yeah,
destination.
exactly. Yeah, you can't return back. There's not one answer, right? This returning back the array says, hey, I wish I could give you one answer, but if in fact I don't know where it could move to. So you have to account for the fact that even though you said move grave 1, or rather grave 2, and it comes back with 1, 3, it's like you have to handle those possibilities.
Right. Like, given a current state, give me back in future states that may occur.
Yes, and possible states from here.
Yeah. Okay.
And then so what we did is we defined a function called night, and the idea is that it takes each of the positions, right? Then it calls move. It maps over it and calls move on each position, and then returns kind of the next possible positions if it was at the position beforehand. So 2 could now be, if it was in 2, it could now be in 1 or 3.
Mm-hmm.
Yeah.
Same for like 1, same for 3, and then so we just go and flatten. We get this list, and then we flatten that list, and then we remove the duplicates, because we don't care if you're now at the same position. You're always then the next night you're going to move in tandem, so we don't have to kind of double keep track of double the work.
Mm.
So that's what night does. Night simulates, the moles, it simulates a mole moving to a different grave. And the reason it's an array is just to capture the fact that the mole could be in multiple places. We don't know. We're going to keep track of where it could be.
Yeah, cool.
Then we've got the old dig. Dig's a lot simpler. Dig just says, give me the graves, right? Give me where you think the mole could be. Give me your guess where you want to dig, and we're just going to pull that out of the array. So here, if the graves are 1, 2, 3, and you want to dig 2, we just give you back 1 and 3.
Mm-hmm.
So this is kind of how we're going to, digging is kind of the idea is that digging is what kind of reduces the size of the graves that we think it might be in. That's our only tool here to get us home, is strategic digs, or digs at the right spot should put us in a position where we make this array empty.
Huh.
So the idea to solve this is basically said, okay, wouldn't it be nice if there was like a function called solution that you called it and it just gave you back the sequence of digs? You just go bang, and then you go like, all right, cool, I'll just go solution, and then it returns you back like, oh, you just have to do 1, 4, 2, 3, and 5, and you're guaranteed to find the mole. So to do that, basically what we have to do is we have to define a function that can like generate all the different combinations. So it can do, it first tries just 1 by itself, and then 2, and then 3, then 4, blah, blah, blah. And then it tries 1, 1, then 1, 2, 1, 3, 1, 4, right? And so we're going to generate all the possible sequences that you could try at each length, and hopefully one of them says, yes, we got it, that works.
Cool.
So what we'll do is, so our solution function basically will say, all right, for each guess in that sequence of all possible guesses, we want to call check with the guess, which basically simulates running that sequence of digs, and it returns back the remaining graves. So these are the graves which there's still a possibility that there could have been a mole in that position. How does that feel? Does that?
Yeah.
Do you feel good about that remaining array?
Where's our grave permutations function?
Yeah, I think we started implementing that. Oh no, that's where we got to.
I want to make sure I didn't miss something. Yeah.
No,
okay, cool.
No, it's a built-in.
Oh, perfect. What is this language we're using?
Yeah, I think this is Scala. Yeah, yeah. This is moles. Yeah. mole. Yeah. So does that like? I think before we jump into implementing grave permutations, does that
Yes.
kind of make sense as like an approach that if remaining, like I guess we just finish this off. If remaining dot length is less than 0, equal to less than 0, that means we've solved it, right? Because that means there is no chance that the mole's in any other grave.
Yes.
We've got it. So that's like we've won. So we can just return that guess.
Yeah.
Otherwise, we've got to keep on going. And then here, if there's nothing, we can just return null. And I think what will happen, that's fine. All right, so let's quickly just implement grave permutations. So the idea here is if I call it with, say, 3, I want an array that's like 1, 2, 1, 1, 1, 2, 1, 1, 1, So everything from 1 up to length 3.
All the way to 3, 3, 3, right?
Exactly all the way to was it 5, 5, 5?
Oh, because we've got 5 graves.
Yeah.
No, I got you. Sorry.
So that's what we want. So if that does that, then we're on.
Right.
So I guess we can just start with the base case, right? If n's less than or equal to 0, we'll just return something. I'm not quite sure yet what we'll do, but we'll return something, right? Something gets to go back there. Now, really, the pattern here is what we do is we can kind of think of this as, well, give me all the permutations for 1 less than n, right? So if n was 3, give me all permutations for 2, and then I'll just whack on 1, 2, 3, 4, 5 at the front of each of those.
Yeah.
So I could say something like, give me 1 less, and then I'm just going to like stick on, so if this was, n was 3 and this was 2, then I would get like 1, 1, 1, 2, 1, 3, all the way up to 5, 5, and then for each of those, I'd put on 1 for all of them. Then I'd put on 2 at the front for all of them, then 3 at the front or the back to fill out the next kind of, the next number of, so from 2 to 3, I can get from 2 to 3 by just whacking on each combination to 2.
Yeah.
So what I'll do is I'll say, okay, sweet, for each of these, I want to, or rather, for each of these, no, what I really want to do is I want to say something like, I've got grave dot 1, grave dot 2, grave dot 4, grave dot 5, and let's just call this all graves.
Got it?
Right, so we'll say all graves, and for each of the graves we want to map over it and get the grave out. And then we want to call grave permutations for n-1, and we just want to return, what is it? We want to return the grave concatenated with all those graves. Or rather, we could do something like grave and then just spread those. Right, so now this will do the job of, oh no, that's close, but not quite right.
It'll be
Yeah,
but that's returning an array, right?
Yeah, so we actually need to, for each of the graves, we need to map over each of the permutations for the layer down, for level down, and here we would say, okay, so this is kind of like next, and here let's just call this G. So here we want to shove the grave at the start of the sequence.
Yeah.
So now this will be, this here, right, will give us, this will be every version, every sequence that's one less, plus the grave shoved at the front.
Yep.
Why do we want that?
Just so that
Why
we can... There you go.
Yeah, add that out.
Basically, the idea is that we want to have those combinations because that's what we're going to basically check. So we're going to so for each of these combinations, and these combinations just represent the sequence of digs. For each of these, we're going to say, like, for example, give me just one. If you just dig one grave, that's it. We're going to run that and see if that works. If that works, we go, great, here it is, there's a solution. But if it doesn't, we move on to the next one. We say, okay, what if you just dig 2? Up to, what if you just dig 5, 5, 5 and see if that works?
So it's a bit of a brute force approach.
It's definitely, it's a brute, that's exactly what it is. It's brute forcing all the whole solution space. And we've just...
all combinations and then testing them.
And then testing each one. And this actually be a pretty good candidate for something like dynamic programming, where you might be able to like leverage some sub kind of structure that you could reuse. But the kind of core thing here is that the kind of complexity comes from how do you model this interaction where the mole could move, into spots that you don't know about.
I've got a question.
Hit me.
Why is dedupe called dedup?
Mate, you're asking the right questions. Where do we do? Where's dedupe? There it is.
Yeah.
Dedup.
It's
Same
dead
one
up.
character.
You're bringing the dead up.
Oh, you're bringing the dead up.
Yeah.
Of course.
Bring
bad.
it. Yeah.
It's
So-
shorthand.
It's short. Yeah, that's right. It's a startup. It doesn't have any vowels.
You keep-
All right. So I've just copied over what we had from
How
last
many
time.
how many permutations are we going to run?
Yeah. So like there's a
999, I reckon.
Well, all right. That's you don't reckon it could be done in less than that? The funny thing here is that a good implementation of this, actually, you don't say, like, you should actually use a generator to kind of just yield out the results, right?
Yeah.
As opposed to like trying to pre-compute them and then iterate over them. But that's like, yeah.
Or until steam starts coming out of your computer, at least.
What's that? Yeah, exactly. Until it starts burning, you can do it this way.
Generators are not new to me, so am I right saying a generator you can just increase? I was like, I just want to give me the next permutation. You don't need to give them all at once.
Yeah, exactly. Like, you just be lazy. I don't want you to go off and do that work when you like calculated 1 billion permutations and the third one worked.
You literally get a next function back, don't you?
Gotcha.
In a generator. .next on there.
Yeah, I mean, exactly. And if you use it in you could just use it in like a for of loop where it would do that kind of next thing behind the scenes for you.
Cool.
But
haven't you got a return in there if there's no, if the length is 0? Yeah, wasn't there?
Yeah, I had a like a.
It was inside solution, I think. Yeah, if remaining length, so that would stop it there anyway, wouldn't it?
This is just for the recursive call because you're recursively calling into guess permutations here, and so this is just the base case. It just says, hey, once we got to 0, stop trying to calculate anymore. Just return back an array, a 2D array.
Okay. Yeah, no, I meant the other one. The one in if remaining length. Oh no, but our permutation constructor would still run through everything.
Yeah, exactly. It's going to just go off, like, exactly right. Like, it's going to go and compute that all that at that point right there.
Yeah. Okay.
So let's just let's run it. We haven't got. Let's just pretend we have check, and this can just return 1. And then what do we get here? It says there's a lot of things. What's it saying? Grave permutations, doesn't know a thing about that, and that's because I've called that guess. All right, that's better. I mean, fair enough. Can't complain there.
Bloody TypeScript.
Now what's it saying? Saying, oh, that would also make sense. Can't have your cake and eat it too. Now it's saying check guess. All right, sweet. So it's like, hang on. That thing there is a what? Is a string. Guess sequence. Interesting. Expected 0 once we got 1.
How did you define the enum for that?
For which one was it? This grave.
Oh yeah, that should be a number.
Yeah, so I mean now that problem there should be going back checking. So now it should just be whinging about guess. So it says return guess. And it's like that's not a guess sequence. And yes, it is a guess sequence. So what's going on?
Well, hang on. What does check take? Doesn't check need to take a guess sequence?
Yeah, so I mean, it will.
Yeah, is that going to fix it?
Well, no, because here we're just going to hard code. We're going to say this returns
yeah.
a guess sequence. So guess here should be, that should have the type guess sequence.
Yeah,
But
yeah.
Aren't you returning the numbers instead of the permutations return?
Dave.
Never
Come
even used
on. Round of applause for David. Look at this. Unreal. That's it. Yeah.
That's it. I'm done.
He's done. My work here is done. The legend himself. All right. Well, that's good.
Oh,
we were looking.
News gonna come back.
So, okay, perfect. So this is, if we have a look now at our guesses, we should have a beautiful printout of all the combinations. No, that's we're not calling it.
When is restarting? What's up? Let's do NPM. No, what's it? I was just checking what's up to date.
No, MPX.
There we are.
It actually calls down TS on the first time and runs it. It's a global package that's getting executed. Not on the local, but it must be cached because you can't do MPX every time and pulling down TS node.
So it's like pulling it down, but then say, oh, there's a local.
It must be.
So how about that? We just look at all the combinations in length 5.
Like picking a lock.
Like literally picking the mole lock. So we're happy with that, and all we have to do now I've got the permutations, right? We just need to be able. We need something that says you give me a sequence, and I can check that it works, right? So this is the final piece, really. I've got it.
This has all been just setting the scene so far. We haven't actually figured out.
We've just been enjoying the atmosphere, right? We're just been smelling the roses, tasting a bit of wine here and there. But now we're actually going to go and pick the grapes off the vine.
Or dig up a grave to be.
Well, yeah, it's one person's digging into other person's tasting wine for for someone in the profession.
Right.
3 minutes.
Oh, sorry, no
We
more
can do
jokes.
it.
Sorry.
So, all right, we got to guess. What are we going to do? So, this is what I propose, right? Well, let's take the first guest out, and then worry about the rest later.
Classic functional program.
So, let's take guesses. That's actually even better. Well, no, because we might need to pass through empty. Geeses. Sweet. So, okay, get the guesses out, right? Take out the first one. We say, all right, well, this is there's a slight trick here, but we can kind of think that, well, all right, I've got a guess. That's great. This first is a guess, and I kind of want to run it against like the next state. So I kind of want to do something like, all right, there's a dig function, and I pass it an array of graves and a guess. So I kind of can give it this part, right? I pass, my guess is first, right? And this will give you back a, what does it give you back? Oh, it just removes so that gives you an array of graves back. All right, so that's fine. So now that's kind of like after or something. And the tricky part here is the dig part. What's going to go in here? This is kind of like, this is this current state of kind of keeping track of where like each position that it could be in. So if we go like, all right, well maybe we need to pass down the state as well that keeps track of where all the where the mole could be at any given day. The state's going to capture that. It's going to capture this part here, right? Where it exists, where the moles could be. And in the case of 2, it's going to capture, these positions. Mm-hmm. So if we take that, if you could just pass in state, then we're laughing, right? And this is an array of graves.
Yeah.
And then all we have to do is we just have to say, okay, well then we kind of do that, and then we need to kind of deal with the rest. We've done the first one. Now we've got to say, like, okay, well then I want to dig the rest of the graves. So I want to call check with the rest and the state after.
Oh, a little recursion.
I thought we could do it. I saw the minute. I thought it could be done.
Such a tease to drop out right there.
Zoom was just going, nah, you don't get to enjoy the fruits of the solution. You gotta wait next week. David, did you make it through?
We just finished it. Do you want us to walk you through it?
Yeah, I mean that would be great because I'm struggling.
I know we have used a lot of time, but we only have meetings with each of you after this, although they are not the same meeting.
Well, I reckon if it's not wrapped up in 5 minutes, we have to call it.
Okay. Damo, it probably affects you most of anyone because I think you and me have a meeting now, but Cam and the 3 of us are meant to have a meeting before that, which we're now running into.
I'm super flexible.
Okay.
Okay, great. Well, how about I just ping you after we're done with that meeting that's after brown bag.
Yep, sounds good.
Okay, perfect.
Thanks, man.
All right.
All right.
So, all right. What's our confidence level that we can finish this in 5 minutes out of 10?
0.
Well.
Yep, that's good. That's a good start.
Mine is the first guess of the confidence.
The probability.
Yeah.
All right. So wait. That's right. We said this is we kind of had this. We're here, right? So we said, all right, look, you give me a sequence. I pull out the first one. I try that. I say, just dig that one. It comes back and says, okay, sweet. This is where they could be after you've just dug, right? So let's just say like after dig.
So can I just ask, like, where is it getting the initial state from?
Yeah, that's the missing link.
Okay.
That is the missing link. So exactly right. It's like, well, what does this initial state look like? And the initial state, that would look like here, right?
Oh, so like all the graves, right?
It's gonna be all the graves, exactly, because we don't know where it could be.
Could be in it. It's all possibilities. Okay, gotcha. So then we're trying to eliminate, and then just keep digging down that retreat.
Keep on digging until I see no moles left or no positions left.
Right, and so the first time it hits the bottom of that function, it will pop up and say, "I found it."
Yeah, so exactly. So in terms of check, what check will say is, it'll basically go like, look, I'll either return back an empty sequence, or after I've tried all your guesses, you may still have some remainder. You still may have some positions that could have been, it still could be in.
Gotcha.
So I think that looks like kind of, I think that's it. I think that, I mean, I'm pretty confident also that I'm equally as confident that that's not the correct answer, but let's just run it and see what it says. Here we go. There's a little drum beat. Also, I think my console was just running out of memory.
Yeah, I think so, because you just left that thing. Oh, it did.
Here we go.
Are you still printing to the console every potential?
Yeah, well, I was just then. Yeah, every reload was just printing out the whole solution space. But what's now saying is it's just recursing infinitely. So what's going on? So check it's basically saying check is just crashing because it's not stopping for a base case, which it should. Maybe I need to just check if guesses is here. I'll just return the state.
Yeah. That's what we're waiting for, right? What?
So it gives us a solution 4, 3, 2, 1, which that's not correct. So I don't know what it's thinking. So it reckons. Here you go.
No, that's cool. I'm just thinking it through.
So maybe I'm not. Oh, okay.
We're not splitting.
Yeah, you know what we're doing? We're not even moving the moles. The moles are just there, and then we're just digging.
Until we run out of graves. Okay.
until we get them all out. So we have to let the bastards move. So what we really need to say is, okay, the first thing we're going to do is they're going to let them move. So we're going to call night, and then we're going to dig.
Oh yeah.
So I'm pretty sure we don't. Yeah. So solution.
And night just mutates the state. Yeah.
Yeah. So night takes positions. Yeah, exactly. So what we'll say is, we'll say after night, night on the state. Yes. Now it's like, okay, we gave it now. It returns us all the possible states, right? So we give an array of graves.
Yes.
And it gives us back an array of graves.
Yes.
So now you say, okay, sweet, that's what we're going to try and dig at.
It's thinking for the right amount of time, but it's giving the wrong answer.
So we null. Okay, so after the night, we dig. We pass that through as the state. We get after dig, and we do the rest. So like that, there's one missing piece here. We've got night. Okay, so we get the first, we call on state, we get the after night. I mean, it makes sense. You get after night, you get all the possible moves. Then you try and dig on that, and then you pass through the rest of your state. Yeah, we get null. Now, I'm pretty sure the solution is 5 long, so I don't think that should have a difference.
Is there a rest at that point? Yeah.
Is there what? What's that?
I was just wondering if there's a rest or if there's only one element in the array. So you've got to, like, is it rest?
Well, yeah. I mean, yeah, if you say remaining here, right? If it thinks it's got, well, this will be empty. Remaining will be empty if the guess is correct.
No, sorry, I'm looking on 7 lines above. I'm just wondering if that rest is null.
Hey, look at this little solution there.
So it was six digs then.
It was 6 digs, exactly.
Oh, that's it.
So
mate,
if you
did
dig,
that 7 minutes.
What's that?
You said 5. I mean, 7 will give it to you.
That's null void. That is as null as that first attempt on the solution. So that's I mean even if like 4 3 2 1, but that's if you 4 3 2 then 4 3 2. It doesn't matter where the mole was on the first night. You are guaranteed to dig it out.
Look sus. Run it again.
All right, here we go. Oh, second time's a charm. It's holding it strong.
Wow.
So is this assuming that you could potentially catch the mole on any of these days, or is it like...
No, that would be like, yeah.
So this is like worst case scenario, it would take you 6 days to catch it.
No, I think this is like the best case. So this is like on the last day when you dig up 2, you'll get it regardless.
If it started in 5, it might take you till day 6, but if it started on 2, it might take...
What if it was in 4?
Yeah, it's actually worst case scenario on the correct solution. Because best case scenario starts on 4 and you pull up 4.
What if it starts on 4?
Yeah,
you got it. Yeah, exactly. No, that's exactly right. Yeah, if it starts on, well, yeah, if it moves into 4.
Or if it moves into 3, maybe that's like moves into 3, you catch it on day 2.
Yeah, exactly. Like, well, you could catch it on day 2 if it went the right way.
Yeah.
For you to get it, but you're right. Exactly. This is worst case. The last day you get worst case. Last day you dig up 2 and you've got the bugger.
Sweet.
We could check that, couldn't we?
Well, yeah, you could step it. You could
4. Okay, if it's not at 4, then it's at 1, 2, 3, 5.
And then you could walk through it like this.
We could walk through it to like.
Yeah, you could say, you can come here, right, and say, all right, M3, M4, M5. So day 1 passes, and we would say, so 1 could go to 2. 2 could go to, well, first thing is, it moves first in our case. So first we move, right? So we say, okay, well, 1 can go to here, 2 can go to 2 or 3.
Yeah.
Get back there. Where can 3 go? 2 or 4. That's fine. 1's there, so we dedupe that out of there, so that doesn't matter. And we said, well, 3 can go to 4, so 3 goes there. 4 can go to 3, it's already covered, and 4 can go to 5. And 5 has to go back to 4, and that's already covered. But then we can dig. So we can dig 4, right? So that goes.
We're looking at M1 at this point, right? Yeah.
Well, we're looking to get rid of them all, because this is M1 here represents if the mole was in place 1 on day 1, where would it be on day n?
Yeah.
Oh, we want to get rid of all of them. I see.
Yeah,
Okay,
yeah.
I got you. I got you.
So now it's like, all right. What's that?
Oh, yeah. I got you.
So now, jizz, what was that?
So we can 2 go. Right, 2 can go here. 1 can go
Classic
here.
Zoom behavior.
What are you saying?
Huh? Yeah.
Nothing.
All right. And what's that? So
The
1. What are you saying?
It's the kids in the back of the class.
Yeah, I need attention back there.
You know what I was thinking? This is like our life now. Like, this isn't going away. Zoom isn't going away. We should, like, invest in good like, we're getting calls all the time. We should invest in, like, a good camera and good mics. Do you know what I mean?
Yeah.
This is it now.
You look,
This is it.
yeah, you look horrible from here. I must admit,
Thanks, mate.
look absolutely disgusting.
Thank you. I've been working on it. Okay, so where are we at? Day 2?
We're on day 2. We haven't even made it through day 2.
We haven't even we got 6 days. You got to get through.
Why did I say
I
this? Still eating into
We're going to manually go through the 12,000 potential.
Yeah, it's,
We're on a program to do this.
Yeah.
Why are we walking through? Anyway.
Okay, good stuff.
we should get a little printout of what happens if you. Oh, you could do that. Actually, yeah, that's way simpler. Let's just do a little printout. We just throw. We just get checked to say.
Oh yeah, you can print to stand it out.
We can just say stay after dig, and then we just call check with what is it? 4, 3, 2, 4, 3, 2. All grays. And that.
Okay.
So
Oh,
it's
look at
in. Look at that. So
That's what we said. Yeah, totally. That's what we
is that,
said.
it works out exactly. So yeah, it's in 2, 1, 3, 5, and then it could be in 1, 2, 4, could be in 1, 3, 5, could be in 2, could be in 1, could be in none.
Huh. Man,
Love it.
That's so cool.
And
That was the best time I've had all day.
hard to believe, David. Very hard to believe.
Marco, that was pretty good.
Okay, sounds good.
See you guys.
All right, thanks, Damo.
See you later.